show you how easily you can test Java EE and also, by extension, Spring applications. So a little bit about me before I get going. These are my coordinates. I'll have them up at the end of the presentation if you have questions. I was co-author on the EJB3 in Action 2nd edition and also on the NetBeans certification guide. And I'm also a member of the Java EE Guardians. So this presentation, I'm basically going to take you through how you can easily test EE applications. Now, traditionally, testing Java EE applications has been challenging. The first impediment that people often run into is control of the container. How do you actually control starting up the container, deploying your application, and then actually running tests? So in the past, 10 plus years ago, this was kind of, a custom for practically every company and every development team. They would implement their own custom scripts to try to control the container. They'd have custom testing harnesses. They try to reverse engineer the container to get code in there to execute stuff. And it was really hard. In many cases, the integration test, there was really no integration testing. You had unit tests. You might have created some type of test harness trying to test what was going to happen in the container, but you really couldn't easily test code in the container. So that tied into that was, it was challenging to test infrastructure. You'd have to have complex environments set up for testing JMS databases. It was practically impossible to do mocking and simulation of stuff. And then even at that time, JavaScript testing, user interface testing was primarily the domain of the QA group. So you could not easily, create an environment, script it, and test it. And then that also includes web services, trying to test and verify web services. So throughout this presentation today, I'm going to show you how easily it is to do all of this and how trivially it can be done. So the development environment that I'm assuming going forward is, first of all, that you're running in a Maven or Gradle build environment, that you're using one of those two tools. If you have an older AMP-based build system and your application is older, it would be practically impossible to take this approach. You'd have to move it over to the newer build tools. I'm going to integrate Docker into the presentation, assuming that you're using at least Java EE 7 or greater, Java 8, and then your JavaScript front end is using Node.js NPM to manage dependencies and to compile the code. And I'll kind of get into that as I go through the presentation. So the components of EE testing we're going to look at today are Arquillian and some of the interesting Arquillian extensions. Arquillian Cube, which allows us to easily control Docker. So we'll see how easily Arquillian makes it to test enterprise stuff, and then how you can use Arquillian Cube to build up more complicated testing environments and deploy them. We'll also look a little bit at Gradle Docker plugins and also the Gradle NPM integration that allows us to kick off NPM builds and run JavaScript unit tests as a part of that. So we'll kind of integrate it all together. So this isn't just a presentation about Arquillian. I'm also going to pull in a little bit of a discussion on Gradle and its integration with Docker, and also look at the kind of the JavaScript lifecycle, because many applications nowadays are no longer using just JSF, right? So you have an Angular front end with components. You're writing the code in JavaScript. You need to have it transpiled, etc. So I'll talk about how to test that and how to integrate that with testing of your application, so you can actually have code written in TypeScript that you're compiling as a part of your build, and then running unit tests that actually call into web services on the container. So the types of testing, which I kind of briefly touched on, there's unit testing. You can actually make more testing types than just this. I'm just breaking it down for these two for the presentation. But you've got your traditional unit tests, which are fine-grained, which you're testing individual building blocks that make up the application. So you're testing a given method to verify that it does the right thing, right? That it formats the date correctly, etc. So it's really focused on methods. Integration testing, which is what this presentation about, is more coarse-grained. You're actually doing functional tests of the application. May not be the entire application together, but you're testing parts of the application. You're testing the full stack, so you're testing the back end and the front end. You might even be doing unit tests, integration tests where you're testing blocks of JavaScript code and making sure that they're able to communicate with the back end server correctly. parse the JSON, handle errors, etc. And the integration tests are container-based, which means that we're actually running them inside of the Java EE container. So introducing Arquillian. So Arquillian is a testing framework that leverages JUnit or TestNG, depending upon which one you're using, to test code running in a Java container. It is an open source project. It's part of JBoss. It's been around for several years right now, at least going back to around 2009, I think. The framework itself is composed of 3 parts. Test runner, which you use with either JUnit or TestNG. Containers, such as your Java EE container, such as GlassFish, Wildfly, WebLogic, WebSphere, etc. Test enrichers, which integrate the code into the container that's executing. And then finally, the other kind of component, which is a little bit separate, is a shrink wrap, which is a utility that allows you to dynamically build up the deployments. In the past, testing enterprise applications was hard because you had to somehow integrate your testing with your build system, right? So you had to somehow build up a deployment or a partial deployment that you could test. And that's what we'll see that shrink wrap helps with. It allows us to build up custom deployments of parts of our application or the entire application and easily deploy it to the container without having to involve the build process, without having to kick it off. So what can Arquillian test? Well, it can basically test all of Java EE. So it can test CDI, EJB3 beans, JPA, JAX-RS, WebSockets, JSF, servlets, security, etc. So you can basically use it to test your entire application. So you can verify that your WebSocket protocol is working correctly. For some of the WebSocket stuff I've done, I initially developed Arquillian tests that test it from Java, and then I write JavaScript tests that verify that it works correctly from JavaScript. But I'm actually testing against the real back-end server. The nice thing with Arquillian is that I can even mock out parts of the back-end server. So I can be talking to a JAX-RS web service, and I can simulate errors coming back from the server. So I can test to see how is the JSF code, for instance, going to respond when an error comes back? Does it display the correct error message? What happens? I can test security. I can test that you can't access certain resources unless the role isn't correctly set, right? So this is one of the nice things with Arquillian is you can test all of these really hard things as a part of the application. You can do an integration test where you verify that your web services are all properly logged out and require authentication, so that if that changes, you'll know that. So this is really full stack, application container testing. Now Arquillian, there's the core Arquillian, which we'll be talking about, and also there's also several extensions to it. So there's Drone, which you use for testing web-based application. It leverages the WebDriver from Selenium. So Arquillian and the Selenium plugin has very nice integration so that you can go into the Selenium IDE over in Firefox, record tests of your application. It'll generate Java code that you can then use with Arquillian. Arquillian will fire up the container and will make the calls in and verify that your web interface is running correctly. So it's a very nice integration with Selenium. Graphene is an extension for the Selenium WebDriver, integrates with Arquillian Drone, adds some additional features for like page objects, and it gives you a more robust way of writing the tests that go against the page. Warp enables server-side tests to be executed on an HTTP invocation. The persistence, which we'll see a little bit about, allows us to do database seeding and database comparison. So this allows us to get an initial state, insert some data into the database before actually running a unit test. This integrates with DBUnit, which maybe you tried to integrate into your tests before. So before you go to run your application, you can set up the database, preload it with data, etc., and then run your integration tests. And then also performance and regression testing. So you can actually annotate methods specifying the maximum amount of time that they'll take to run, and it will track it so that if the performance changes over time and you subsequently do another run on the machine, you can find out whether the performance is degraded. Has somebody checked in some code that makes log intakes twice as long today, right? Those type of problems that you run into, or things that you want to catch in testing, Persistence, you want to find out, is your persistence layer functioning correctly? With performance, you want to know whether the performance, whether the performance of your application has changed. Now with Arquillian, there's different container types. So there are different interaction styles with the containers. So the first one is remote, which means that the container resides in a separate JVM. There's managed. Now the difference between remote and managed, with managed Arquillian, it's a separate JVM, but Arquillian is responsible for starting and stopping it. Remote, the container is already running on some remote machine, so you may have that in some type of QA environment where you have it set up and you want it to deploy code to it. And then the easy one, or my favorite one, is the embedded, which resides in the same JVM. Which means that within your unit test, it actually fires up the GlassFish, for example, a GlassFish container inside the JVM that the unit tests are running in, and actually deploys your code and runs the tests against it. So you got, depending upon what you're testing, you'll pick one of these three. In terms of the container capabilities, you've got the full Java EE application server, so it can test JBoss, Wildfly, Pyra, etc. WebLogic, servlet containers such as Tomcat and Jetty. So even though this presentation, I said targeting Java EE enterprise applications, that could also be a Spring application running inside of Tomcat. Arquillian can control that. Standalone bean container, so it can work with OpenEJB and Weld SE. So if you have a module for your application that uses CDI, and that module always runs in an application container, you can actually test it outside of the container using just CDI. So if you have like a core library that uses CDI when it's deployed, you can test that. You can test how all of your injections work, your producer methods, etc. Arquillian also supports testing OSGI containers as well. In terms of the supported containers, I believe this is missing the Weld and Open WebBeans line in here. But you can see we've got, for GlassFish, you can see the containers and the list of supported deployment methods. For WebLogic, it supports managed and remote, but it doesn't support embedded. The rest of them support embedded, managed, and remote. Some of them are more complicated than others to set up. The easiest one to actually get up and running with is probably the GlassFish Pyra. That's a simple jar file, so it's as much easier. For using like the managed or the remote, it's a little bit easier. Now for your tests, there's two type of modes. There's in container, where you're testing the internals of the application, so you can actually your tests are actually running inside the Java EE container. So you can actually introspect things, you can have beans injected, and you can work with it. This is the default mode. You can also test as a client, which tests how the application is used by clients. So in this type of test, you're executing theoretically remotely, and you're testing web service calls, etc., and seeing how the system responds. You're not running code that's actually executing within the container. Now, one part of setting up the test is something called test enrichment. So within your tests, so your tests are just JUnit tests, so we're not using a different JUnit framework, you're using JUnit, but you get injection with it. So you can inject resources, you can inject EJBs into your test cases. Your persistence context, so if you want to set up the database, you do some operations, you want to check, use your data model and use GPA to check to see whether the data was persistent or not, you have access to all of that. So you can have the persistence context injected into your test cases. In terms of context, depending upon what you're doing, you can test and run, like request conversation scoped, session scoped, which is a session, which is the test class itself, application, which is a test class. So you can test, request scoped, application scoped stuff. In addition, you can also use interceptors and decorators within your tests. Now, adding Arquillian to your project is not very complicated at all. It's very simple. You add the Arquillian BOM to your Maven file, and there's some similar code for adding it to Gradle. And then you add, of course, JUnit and the Arquillian JUnit plugin for using JUnit. Of course, this would be different if you were using TestNG. And then finally, you add your container type. So in this case here, I'm adding in remote GlassFish container. Now, if I was doing embedded, this would say, instead of
Arquillian GlassFish remote, it would say GlassFish, or sorry, Arquillian GlassFish embedded, and I would be working with the embedded container. And you set up different profiles depending upon what you're doing. So just in summary, for setting up, you set up the Arquillian bomb, the JUnit Arquillian container, and then basically a testing profile. So if you're only working with one container, you don't have to set up necessarily set up profiles. If you're working with multiple containers, you'll need to set up a different profile for each, Maven profile for each one of the containers that you want to test. And you add that in, and that's how the system knows which container you want to use. And then this is a simple hello world example. So up at the top we have our, this is our JUnit class, and we use the JUnit run with, and we specify that we want to use the Arquillian test runner. Okay. Now the first thing to notice that's a little bit different with this test is we have an EJB, an EJB injection point. So as part of this test, I'm actually having an EJB injected into my test case so that I can then use that in my tests, right? So I can talk to EJBs, I can work with, I can ask them, so that's the EJB that I'm actually testing in this test. So I want to get an instance of this EJB, and that's what I'm going to test in the test method down below. Now we also, since we have run with, we also have to have a deployment annotation. And this is where we build up the WAR file that we're going to use for testing in GlassFish. So this is using shrink wrap, which I'll get to in a second. But I dynamically build up the contents of the WAR file. So I can say use a web archive and give it a name, test.war. And then I can either add packages or specifically add classes to the wars, add the configuration that I want to use, pick which file. So I pick the file locally from the class path, and then what I want it to be called when it gets bundled up into the actual war. So I might use, in the first example here, although I said beans.xml, I might want to, beans meeting tests, and then, of course, gets named as beans.xml in the archive when it gets built. And then finally, I have my test down below. So this test will actually run inside of the container. So I actually get a reference to the meeting bean. I'm talking to it like it's an EJB, the transactions are there, and I can test to verify that it works correctly. So think about this, prior to Arquillian, this was really hard to do. How would you get code into the container that could test an EJB that's not exposed externally to the system? Okay. Now, moving on, I'm going to a little example with persistence. So I had the DB, the Arquillian extension for the database testing. And I have a test case right here. Once again, we have the run with Arquillian up at the top. I have my deployment, which builds up the WAR file, interject my EJB user service that I want to test, have the user transaction injected because I'm using user transactions. And then on the test methods, you can see that I have using data sets, I can apply a script before the text executes. I can verify afterwards, what was expected to be inserted into the database. So I don't even have to write code to, ask the database, hey, give me the list of users that were inserted. So I can using Arquillian and this extension and with DBUnit, I can provide a YAML file that says, okay, this is what the database state should be after the test is finished executing. So this makes it trivial to test like persistence code and verify things that are working correctly. So next, I'm going to take a look at shrink wrap in a little bit more depth. So shrink wrap, which is very important for this whole process, is an API for building up the artifacts, as we just saw. It's a JBoss project. It's leveraged heavily from Arquillian. I think it's used in the main JBoss app server as well. And it has several different supported archive types. So far we've only seen the WAR one. It also supports jar, EAR, and the RAR for resource adapters. So you can test all of these as a part of it. So if you have a complex application that gets built up into an EAR, it's going to be just as simple to build up the EAR as it is to build up a WAR. Right? You can do that programmatically. In terms of shrink wrap terminology, basically it's an archive is a virtual file system. So you're not actually building up something that's going to be necessarily generated out. You're building up something virtually. So you're building up a virtual WAR, and then that's what gets deployed to GlassFish container. File is the entry in an archive, a content or a folder. A a path is a location within an archive where a node lives, and an asset is byte content within a node. So the API, the main class that you work with, the static class, is shrink wrap. It's the main entry point for doing everything. And then, so the shrink wrap create method takes one of the following archive types. You can generate a generic archive, a Java archive, an enterprise archive, a web archive, so they correspond back to, here or etc. what you're trying to generate. So down below, this is just pulling out a simple example, and then it uses basically a Fluent API so that you can then afterwards add resources, as we saw before, add classes, add content to it. So we've got several different types of content. We have an empty asset, which you can use to insert an empty, beans.xml, for instance. We can add string assets, so we can actually, instead of having to have a file that we've got checked into our source code tree, we can actually just embed the content that we want in the file in the string and add it in directly. So we've got several different ways of loading data into it. This is a little bit more complicated example than what we saw before. So as you can see, we're adding in resources down below. We can also, for debugging purposes, we can use an exporter if we want to find out what actually ended up in that archive, right? So we could use a zip exporter to export this virtual archive out to an actual WAR file that we could then examine and deploy if we were trying to debug it. This is another slightly different example. As you can see, I'm using we have the add resources, so I'm adding web resources. So we've got slightly similar example. So that's shrink wrap in a nutshell. It's really easy to use. And the nice thing is that for each set of test cases, you can build up a different WAR file with a different set of code that goes along with it. So if you have startup, you have a singleton EJB that's marked with a startup that you don't want to execute, that it initializes something, you don't include it in your archive, right? If you've got message-driven beans that your tests don't actually use, you don't package them. So you can use shrink wrap to package just the parts of your application that you want to test. So now configuring Arquillian is very straightforward. There's an Arquillian XML file, which is an optional XML file. It's located in the root of the test class path. It configures how to communicate with the server, the port that the server is running on hostname, the hostname if it's remote, etc. And it's where you put the extensions on it. So we'll see some examples of Arquillian XML as we go through. Containers, as I mentioned before in the first example, the containers that are used are determined by what's on the class path. So in this case right here, I'm including embedded, and you can use managed, embedded, remote, etc., depending upon which container that you want to put in. And the important thing to note that is if you look at any of the documentation for using GlassFish, the PyRI group just published an updated set of plugins, I think last week. So you definitely want to use these because they added a bunch of support for EE7 stuff. And then this is the Arquillian XML file. So here you can see this is basically a default one. Now this is actually part of another set of tests that I'm running, so I set up the web driver for some Selenium testing. Under the GlassFish embedded, I specify which port HTTP is going to be bound to so that it knows where to find it. Now this file is optional, and you use this to set up Arquillian if necessary. So let's look at a scenario, more complex testing scenario. So in this case right here, I'm going to use an embedded testing using GlassFish. The application uses JPA and a JTA data source, and the test database is developer specific, which means that each developer has a separate copy of the database. So how do we go about this? So this is your typical Maven project. Now note that the project itself has a beans.xml and a persistence.xml in it. Now when I run the unit tests, I don't want to actually use either of those two files that actually get deployed out to the real production environment. I want to use the ones that are specific for the test environment. So when I build up the deployment, I specify which GlassFish resources XML that I'm going to use, and also which persistence XML that I'm going to use. So you can see I'm pulling in specifically test.persistence.xml from the test class path, as opposed to the one that would normally get packaged up when the application, when it gets built for the main deployment. And the GlassFish resources specifies, because this is an empty version of GlassFish, sets up resources that this application needs, right? So I'm providing to this embedded container to set up, to set up the data sources for the database that I'm then going to use from my tests. Okay, so that's the things that I was trying to highlight right there, are these three things right here. So that beans.xml and persistence.xml are not used. I use these ones for my test class path. And the beans.xml may contain alternatives, so I may have mocked out certain parts of the system and said to use alternates for different things, right? So I might have leveraged CDI in this case to insert other code. And then finally my configuration over there, when I build up the WAR file, I'm specifying that I'm using those down there and I'm completely ignoring the ones up above. Then my GlassFish resources, I specify how I want the container configured, because it's an empty container. And the important thing to note is down there at the bottom, actually during the build process, when the main Maven Gradle build runs, I actually substitute over from the local properties on the local machine, which are system properties, the username and password of the database. Now we'll see an even better way later in the presentation using Docker to do the same exact testing without having to set up anything on the local machine. So I don't have to have a database set up or a test database set up. Okay. So moving on to JavaScript and EE testing. The JavaScript testing has really gotten more complicated the last couple of years. Obviously, code is usually now transpiled, so it's no longer the case that you're just shipping snippets of JavaScript with your JSF pages to do validation of input. Now you're actually, your front end or your EE application is probably running microservices with like an Angular or React front end, and you're doing transpiling down to ECMAScript 5. You're probably using NPM to manage the packages, the JavaScript packages, using state libraries, and then your JavaScript code is using services from the Java EE side. So the typical build type test cycle would be, you compile your Java code, run your unit tests, transpile your JavaScript code, JavaScript unit tests, and then the container integration tests, and then the browser integration test to verify that the JavaScript code that's running in the web browser is able to correctly call to the back end. So this saves you the problem if you made a change to Java code, now you deploy your application, you open the web browser up and see whether the JavaScript code still is able to talk to the back end. You can now automate that entire thing and have it done using integration tests. So in order to do this, as I mentioned, the JavaScript dependencies are managed via NPM. And the implementation, so I'm actually tackling this not with Arquillian, because Arquillian is just for unit testing. I'm tackling it with a Gradle plugin to invoke the NPM Webpack build, because in most of the examples that I work on are using NPM on Webpack. The output is then generated and dumped into the resources of the web application, and then Gradle is able, the Arquillian is able to pick that up and bundle that up for the unit test cases. So this is my Java Gradle build file where I'm using the mooworks.node, which integrates Gradle with Node, which allows me to then invoke NPM tasks from Gradle. Right, so I can run the Webpack, run the NPM stuff, which then invokes Webpack as part of the build, which will then transpile my TypeScript files over to JavaScript, and then I use shrink wrap to pull it together into a WAR file that I can then test all together with my backend Java EE application. So the Gradle plus the NPM, I use that to transpile the code, and then Arquillian to actually do the testing. And then for the Arquillian testing, I use Arquillian Drone, Graphene to do the testing, and we'll see how that. We'll see a couple of examples of that going forward. If you're not familiar with Selenium, Selenium automates web browser testing. Supports multiple web browsers, Chrome, Firefox, and it's even got a headless one, Phantom.js, that allows you to test the JavaScript code without firing up an actual web browser. And the power of using this with Arquillian and the drone stuff is that you can actually test different browsers easily without even having to have them installed on the local machine. With Selenium, which ties in nicely with Arquillian stuff, you can use the Firefox IDE For Selenium, for recording operations, it generates Java code that you can then paste into your code. So it takes a lot of the nitty-gritty finding the elements, etc., to work with. Selenium supports multiple browsers, so it supports, of course, Google Chrome, multiple versions of Internet Explorer. The trick with the Internet Explorer one is that you actually have to be running the tests on the Windows platform with those browsers actually installed. Firefox, Safari, Phantom.js, which is usually the one that I'm using for like headless testing if I'm building on like a Linux box. And you can also do testing for the mobile platforms using Appium. So you can get, with this integration testing, you can automate testing of your application with the Java EE backend, both for mobile and also for desktop. So this is extremely powerful. So this is the block of code that you would add in for your dependencies for using Selenium. So in this case right here, I'm pulling in the Firefox driver, and also the Phantom.js drivers. I'm going to test with both Firefox and Selenium. I then construct the war, and so this is a slightly more complicated example than what I showed before. So I'm actually pulling in all of the HTML files that make up the application. I'm also pulling in, under the tests, I have JavaScript and HTML files, spec runner, etc. So I have the infrastructure for doing the JavaScript unit tests that I'm also pulling into the war files. So when it deploys the application, I'm deploying not only the final HTML code in JavaScript, I'm also deploying the test JavaScript code in the war file so that I can then execute that in a browser. So I can actually call up a page and run the JavaScript test, which then call off onto the other JavaScript functions, which are a part of the application. So this is an example JavaScript unit test written in JavaScript, and it's actually a test that invokes the container. So here I'm testing some JavaScript code to verify that I'm verifying how the error messages are going to come back from the server. So I'm actually sending over invalid content to the server and verifying that my web service responds correctly with a JSON message with a list of errors. So that's what this test is testing. So this allows me, using Arquillian with this whole this ecosystem, with a Gradle plugin, allows me to test that I fire up my backend server, I make AJAX calls to it, and I verify that if I send it bad data that it replies back and that my JavaScript code is correctly handling that and handling the errors. Right? So normally if you're not working in such an environment, you might have QA say, well, the error message didn't come back with everything, or nothing happened. So now you can completely test this. And then this is the Selenium code running, or a slightly slimmed down version of it. You can see that you can, even while it's running the unit test, if you're running with an actual browser, you can have it take screenshots of it. So as you can see, I'm waiting for it to start up and running, and now we'll see when I get to the drone stuff that this gets a little bit simpler, but I'm actually looping through using the Selenium APIs to figure out what exactly came back from the server and whether the test succeeded or failed. So Arquillian Drone, which makes this process even easier, manages the lifecycle of the browser and allows you to easily test multiple browsers in a single test. So if you want to test that your application, not with the backend running, that it correctly works on Chrome, Firefox, IE, etc., then you use Drone. It has integration with mobile browsers, integration with QU Unit, and of course it's compatible with the Selenium 2 with the WebDriver. Related and building on top of this is Arquillian Graphene, which provides a simple API for developing reusable tests. So it's got abstractions such as page objects, page fragments, jQuery selectors for location strategies, etc. So these two projects kind of build upon one another and enable more integrated testing. So this is an Arquillian Drone test here. So as you can see, I get the, once again, we have the run with Arquillian.class. We have a new annotation here, drone, which is giving us a direct reference to the WebDriver. We can get the Arquillian resource, which will give us the deployment URL that the application was deployed to, so we don't have to hard code things or try to figure it out. And then we can use these annotations here to actually inject and get references to specific elements in the HTML. So we get the web element, we're getting an injection for the the username, the field for the username, the password field, etc. And then we can test, doing the registration, clicking on things, making sure that logins are displayed, sending keys, etc. So this allows us to test that UI programmatically. So this code here executes and then tells the web browser to do things for us, which then turns around and calls our backend server code. So now moving on to the next part of the presentation, which is Docker, which allows us to build up an even more reusable environment. So there's two different approaches I'm going to talk with Docker. The first one is using basically your build system. So creating Docker images, oops, I got the rest of that sentence, which is used to feed the downstream Arquillian like drones, Arquillian Cube stuff, and also starting and stopping Docker containers during testing. So you can do that from Gradle, Maven, where you start up Docker and then shut it down for unit tests, or you can use Arquillian Cube, which enables management of containers hosted in Docker. So it reads the Docker Compose, uses the Docker Compose thing to create your running environment. So you can actually create very complicated environments with tests. So you can have deploy several containers with a load balancer, test your failover of your application to verify that failover is working correctly, that state replication is working. So now you can test those really hard things that before were, that you'd require a complex regression environment for. So for the Docker integration with Gradle, there's several different plugins that are available, Transmode, and then Bushmunko, which allow you to build up Docker images. So you could take your application, build up a Docker image, build up several Docker images, and then deploy those as part of your testing. For actually running Docker containers, you've got the Planeteer Gradle plugin, which allows you to fire up images, which we'll actually see in the next slide. Or in the slide after this one. This slide right here, I'm actually building up a Docker image. So I'm taking my application, I'm creating up a Docker image, starting out with the Pyra image, and then adding my application to it. So this is creating basically Docker images in that. This next example, I'm actually integrating, so when I run my integration tests, I need a database, a clean database that's up and running. So I've got several options with that. I could try to write a ton of code that's going to, pull in environment settings from the local developer's machine, try to wipe the database, and then reload the database schema. Or I can use a Docker image. And then as a part of the tests, when it comes to the part of the test that require the database, fire up the database, pass the parameters into the test for the username and password of the database that's there, and run the tests. And then as long as the tests succeed, destroy the database. If the tests fail, obviously I leave the Docker image running so I can then connect to it and see, what data was actually saved within the database. Where did it fall apart, and compare that with the logs. So this plugin has several different plugins, so I can use different methods. I can use Docker run to start, stop, etc. and get the status. So this makes it much easier to test persistence code. So I'm using the Gradle Docker plugin. So I'm starting the PostgreSQL a blank PostgreSQL database. I'm running my integration tests, which load up data into the database, and then finally I'm shutting down. So I could create Docker images with initial data sets that I want to test out different scenarios with, and then for those different tests I could fire up that Docker image and use that, right? And so at the end of it, I throw the database away, so I don't have to worry about maintaining databases. I don't have to install a database locally and keep track of the username and passwords that I'm using and set up environment variables. So it makes it a much more reusable environment that you could check out code, run the tests, and not have to set up anything, which was my goal. So as a part of this, I also added a test list, a monitor test listener as a part of the Gradle process, so that if the test fails, I don't destroy the Docker container. I leave it running. So when I get a test failure, I can then go log into the database and figure out, why did the test fail? Was there, did it get installed locally? And then your Arquillian XML, so you can specify, where your Docker Compose YAML file is. This is a Docker YAML file right here, which is setting up a server that's going to run on a couple of ports. And so then in our actual test case, we can actually deploy our application. We get a reference to the web driver, we get the IP address of the container that the application that's running in the Docker container, and then we can execute our tests against us. So this is an even more complex example where we're actually deploying our web application to a container that's running in a Docker environment. We may have set up, there may have been several Docker containers that started up with that, right? So we may have started up, the database, a load balancer in front of it, and now we're going to run our unit, write our unit tests that go against it. So this is extremely powerful. In terms of challenges with working with all of this, this sounds very easy, and indeed it is very easy to get up and running with the tests. However, error messages are very often misleading, so I can't tell you the amount of time that I've spent chasing down an error message that was completely irrelevant, right? Because when an application fails to deploy or your test fails to run, very often the error message that you get is slightly different than the one that you would have expected. The code structure and complexity. So if you have a large existing application, as you can see, the code for shrink wrap can get quite tedious as you're adding packages and classes manually. So if you've got a large enterprise application with thousands of classes, it's going to be very complicated to try to build that up, right? So structuring your code, making sure that it's in modules is very important. Testing small applications is fairly easy, but larger applications gets more complex. And then the other complexity is that you can't mix different containers in the same runtime. So for example, you can't taste GlassFish and Wildfly embedded basically in the same build, at least currently. So those are some of the main challenges. However, the challenges that you run into once you get used to running this, it's amazing the tests that you can actually build and the things that you can actually test that previously you would have hopped over to the browser to try testing manually, right? So you can test the full application stack using Arquillian. So with that, Java EE can definitely be tested. It's no longer do you have to develop rat's nests of scripts to deploy applications, complex DevOps environments where you're trying to fire up tests, load code into the thing. Now you can actually write tests that have code embedded within it. And so some good resources to get started. There are 2 really good books on Arquillian up at the top. One of them is still in beta that you can get from Manning. We cover a little bit in the EJB3 in Action book where we talk about testing and also the APIs, the EJB container API that Arquillian uses to do some of this. Arquillian website has some very easy to use guides. Literally you can be up and running in about 10 minutes with Arquillian and actually doing tests within the container. They have a huge repository of sample code, so you can download each one of those as a separate test case. So they have a simple example going over how to test JPA code, for instance, how to set up a JPA example. And so there's actually a lot of resources out there. The Arquillian Cube stuff came out a couple of years ago, so the documentation is actually finally settled so that it's actually very easy to use. So with that, I'll have the presentation up later on SlideShare, so if there are any questions, I think we've got 2 minutes left. If anyone has any questions? Okay, if not, I'll be around afterwards. Thank you.